Hello and welcome to our first Teltonika Networks webinar with Leader Computers in Australia. My name is Aisha and today I will be introducing you to the Teltonika Networks operating system and the main features of Teltonika routers. Before we begin, I'll briefly introduce myself. Again, my name is Aisha Shah and I'm working as a networking and IoT engineer at Teltonika Networks based in Sydney, Australia. Day to day, I'm working directly with our partners in Australia, New Zealand, and Pacific Islands. I provide direct technical support to their engineering teams and attend pre-sales technical meetings to help clients find the best products for their projects or help them solve their custom config challenges. This means I'm working daily with the whole Teltonika Networks product range and working within RutOS in various applications. As an engineer, I'm passionate about finding great technical solutions to everyday problems, which is something central to what we are doing here at Teltonika Networks. Because industrial network devices are deployed everywhere, from traffic lights to surveillance drones, we have quite a vast product range with a varying feature sets. Before we get into the operating system, I'll briefly introduce the Teltonika Networks range and cover off the main differences between gateways and routers in networking. The reason for this is that they have very different applications in practice. So by understanding the differences, you can better select which device type you might need now or in the future. Once that's covered, I'll introduce you to each section of the RutOS WebGUI. So by the end of this webinar, you will understand the different features and applications of industrial network devices and be able to plug in a Teltonika network device, access its WebGUI, and complete all the necessary configurations yourself. As we go along, feel free to ask any questions you have in the webinar chat. My colleagues will either answer your question in the chat or if it's relevant to the group, I will answer it. We'll also leave some time for questions at the end. Gateways. In networking, a gateway is a device that connects a system to the internet and acts as an entry or exit point. Gateways are designed to have only one interface and therefore are usually used to just connect a single device to a network. They are also used literally as a gateway between networks, typically to connect two different types of networks together, such as local area network, that is LAN, and wide area network, that is WAN. And on the other hand, we have routers. Unlike gateways, routers can provide internet connection to multiple devices through multiple interfaces concurrently. Routers manage network traffic by prioritizing certain types of data and minimizing network congestion. They determine the best path for data to travel using routing tables. So this capability of handling multiple interfaces and various devices connected to it makes routers very versatile and usefully connectivity devices. Feature differences. The above mentions are some of the differences in how gateways are different from routers. Some of those differences are SIM card slots, industrial interfaces, wireless interfaces, number of Ethernet ports, serial ports, antenna, GPS, etc. As we know, while routers are designed to manage multiple interfaces, gateways usually are designed to have only one interface. So as you can see in the above picture, this is a diagram of how modems, gateways, and routers are different from each other. LTE modems have only one function, and that is they provide internet connectivity to connect a device. It cannot make a connection without the help of software running on a device. So for example, we have TRM devices, which can be used in coffee machines that can be used for monitoring, maintenance, or warranty related purposes. On the other hand, next we have is gateways. Gateways are already include modem, and on top they can connect to one specific device to internet. They have interfaces like Ethernet, RS-232, RS-485, or inputs and outputs. It could work as a simple or a smart piece of equipment. It has software to allow management and connect a device. It has extensive security such as VPN and firewall. Some of the use case examples could be like remote monitoring of oil and gas pipelines, remote monitoring of solar power plants, remote water pump automation using SMS and calls. Followed by we have routers, which include all of the features of previous devices. They have more connectivity options, more ports, advanced software, security features, and in general, faster hardware. Thus, this makes them more universal. This can be used in any use case, such as enterprise, retail, smart city, transportation, industrial, automation, and many others. Now let's talk about operating system. On the screen, you see some of the examples of the companies with operating systems that you are likely familiar with. Like these companies, Teltonika Networks has its own operating system called RutOS. Now, what is OS? The operating system program that we have after being initially loaded into the computer by a boot program. It manages all of the other application programs in a computer. And why do we need it? It brings powerful benefits to computer software and software development. Without an OS, every application will need to include its own UI. So we have root OS in our devices, which is a unified operating system based on OpenWRT used by all our Teltonika Networks devices. This system enables our customers to have an excellent user experience using technical Teltonika routers, since all the devices are easy to use due to an intuitive interface. Our design philosophy is to provide the most secure, easy to use, and reliable product. We are applying the same philosophy to our root OS to make it secure as much as possible and user friendly, which is also highly functional. My favorite part about working with Teltonika Networks RutOS is that the system is very straightforward and well designed for user ease. Anyone can set up their industrial networking device and configure it for use. But it also scratches engineers' itches by providing advanced security features and easily implemented custom solutions through OpenWRT. Let's talk about the security. If the product is not secure, no devices will work properly or correctly. Our device is based on OpenWRT. Our R&D team makes sure of the vulnerability reports and updates. It continues to update the packets. And as Teltonika is a member of CVE, they make sure that all of the updates and uploads are shared with all the related vulnerability and bug reports. Furthermore, our web interface is locked from the beginning and no one can break into it while other manufacturers keep it open in the beginning. Next concept is VPN. VPN is a method of connecting multiple private networks across the internet. VPN can serve to achieve many different goals, but some of its main purposes are access between remote private networks, data encryption, anonymity when browsing the internet. I'll explain each of these VPNs later in the slides. We have another security, that is firewall. Our router has pre-configured rules which are enabled via WebUI. User can use additional layers of firewall rule and has more security and are more versatile. Because firewall is based on IP tables, it gives unlimited firewall configurations. One can customize based on the customer's needs. We also have attack prevention feature, which provides the possibility to configure protections against certain types of online attacks. Now let's talk about the web UI. The default IP that we use for the web UI is 192.168.1.1, and the username would be admin with a default password of admin01 or a random password which is at the back of your device. And this is how your web UI page looks like. As you can see here, this is the web UI page. We have divided that in 4 different sections. One is status, network, services, and system. Let's talk about status first. The overview page that you can see here contains the various information summaries and shortcuts to other pages. It is also the dashboard homepage of the web UI. This page contains widgets that display the status of various systems related to the device. If you are having trouble finding the page or some of the parameters in the web UI, you can turn on the advanced web UI, which is you can just see by using the basic button under the mode, which is located at the top right corner of the web UI. Next we have is system. The system page displays general information related to the hardware, software, and memory state of the device. And the network page contains the information related to the device's networking. It has different tab displays such as mobile, wireless, and LAN. The mobile tab displays the mobile connection information. LAN has the local networks information, and wireless shows its 2.4 and 5 gigahertz of interfaces. Furthermore, we have routes, services, real-time data, mobile usage, and logs. The routes page displays the router's ARP table and active IPv4 and IPv6 routes. The services tab page is used for easy service management. So from here, you can check the status of most services and find a link to each of their configuration pages. Right, next up we have is real-time data that contains the various graphs that displays various statistical data changes in real time. For example, average CPU load values, inbound and outbound traffic load, wireless radio signal strength, peak signals, etc. We also have mobile usage as well. So this page contains the graphs that display the mobile data usage over different periods of time. It could be day, weeks, months, or in total. And here is the logs page, which contains all the information on various device related events. It has different logs such as events log, traffic logs, system log, network logs, hotspot logs, etc. Let's talk about networks now. Then a networking device is basically a computer, small computer like your laptop or your phone. So the primary function of a networking device is to provide internet connections and to send and receive data over that connection. Like your phone or laptop, your networking device has an operating system. It can send and receive commands, and you can run apps or plug in to perform various tasks. So same way, we have network page, which contains all the information related to the device's networking. This is the page where you can see some of the basic interfaces of your device, be it mobile connection, wired, wireless, or firewall connection. So first up we have is the mobiles page. The mobile tab displays the information about the mobile connection and information like SIM card details, connection state, operator state, network type, data transmission. One of the useful feature is the SIM switch feature. This section provides you with the possibility to configure SIM switching rules, that is, set up circumstances under which the device will perform a switch from using one SIM card to another. Next we have is interface page. This is a general page which provides an overview of the interfaces page. It shows the existing interfaces on the device. The setup is used to configure the protocol of an interface and all the different parameters that go along with each protocol. Then we have is the wireless phase. This section of the network tab can be used to manage and configure the Wi-Fi access points and Wi-Fi stations, that is the clients. Next, another useful feature of all is failover. Failover function allows you to get the backup of your WAN connection in case it goes down. So this can be used to keep a backup so you don't lose any connectivity. And on the other hand, we have load balancing interface as well, which is a method of dividing traffic between multiple WAN interfaces. Load balancing can be used to share the data load between different interfaces and increase the overall internet speed for multiple users and connections. Another way that we already talked about security is the firewall. The firewall is used in a standard Linux IP table package. So as its firewall, so which uses routing chains and policies to facilitate control over inbound and outbound traffic. It uses different settings like port forwarding, traffic rules, NAT rules, attack prevention, custom rules, etc. Next we have is VLAN. So VLAN is a virtual LAN. It is any broadcast domain that is partitioned and isolated in a computer network at a data link layer, that is layer 2. VLANs work by applying tags to network packets and handling these tags in networking systems, creating the appearance and functionality of network traffic that is physically on a single network but acts as if it is a split between separate networks. That's all we have for network. Let's start with services part. So services are where you'll find your device's application. By default, your device will have apps installed like GPS for location tracking, VPN for security, SMS, and call functions to communicate with your device. You can also install some custom applications called packages. So here I'll be discussing some of the features that can be very useful for everyone here. Firstly, as we talked before about security, we have VPN. VPN is a method of connecting multiple private networks across the internet. VPNs can serve to achieve many different goals, but some of its main purposes are access between remote private networks, data encryption, anonymity when browsing the internet, OpenVPN. Now we have different VPNs that we have here. OpenVPN, GRE, IPsec, PPTP, L2TP, DMVPN, etc. For OpenVPN, it is an open source software application that implements VPN techniques for creating secure point-to-point or site-to-site connections in routed or bridged configurations and remote access facilities. Then we have is GRE. GRE is a tunneling protocol used to establish point-to-point connections between remote private networks. GRE tunnels encapsulate data packets in order to route other protocols over IP networks. Then we have is IPsec. IPsec IPsec is a set of communication rules or protocols for setting up secure connections over network. IPsec adds encryption and authentication to make the protocol more secure. We have another feature called DMVPN. That is a dynamic multi-point VPN, which is a method of building scalable IPsec VPNs. So DMVPN is configured as a hub and a spoke network, where tunnels between spokes are built dynamically. Therefore, no change in configuration is required on the hub in order to connect new spokes. And another one important is the L2TP, which is also a tunneling protocol which is used to support VPNs. It is more secure than PPTP, but because it encapsulates the transfer data twice, it is slower and it uses more CPU power. Next up we have in the services page is mobile utilities. One another very important and useful feature. This mobile utilities page is used to configure various SMS and call related device controlled options and to read, send and manage SMS messages and SMS storage space. In-depth knowledge about the mobile utilities will be given in the next upcoming presentations in the future. Next we have is auto reboot. Auto reboot, this can be used as a precautionary measure that ensures the device will self-correct some unexpected issues, especially related to connection downtime. We have ping wget reboot and reboot scheduler. We have ping wget reboot function to periodically send the ICMP or wget requests to a specified IP address or host and waits for a response. If no response is received, the device will attempt the same action a defined number of times at a defined frequency. If there is still no response, the device will execute the specified action, that is reboot by default. And on the other hand, we have reboot scheduler, which is a function that reboots the device at a specified time interval, regardless of their circumstance. This can be used as a measure, for example, to reboot the device once at the end of every day. Next up comes is the Modbus. So Modbus is a serial communication protocol and is a commonly available means of connecting industrial electronic devices. In that, we have different features. One is the TCP, Modbus TCP, and another is Modbus serial. We have Modbus TCP slave, which listens for connections from a TCP master, that is client, and it sends out a response or sets some system-related parameter in accordance with the given query. This provides the user with the possibility to set or get system parameters. Same way we have is Modbus serial slave, which listens for connections from serial master, that is client, and it sends out a response or it sets some system related parameters. Next up we have is Modbus TCP master. This device can request the data from Modbus slaves. The Modbus TCP master section is used to configure the Modbus TCP slave. And another we have is Modbus Serial Master, which is a serial communication protocol mainly used in communication via serial interface. One another way is MQTT Modbus Gateway. This function is used to transfer Modbus data over MQTT. When it is enabled, the device subscribes to a request topic and publishes on a response topic on a specified MQTT broker. It then translates received MQTT message payload to a Modbus request and relays it to a specified Modbus TCP slave. Next comes up is input output. Input outputs are used for monitoring and controlling a connected device or received signals from that device in order to trigger certain events. In that, we have input output juggler, post get, and schedulers. The input output juggler is a feature that provides the possibility to create automated rules that perform certain actions based on input state changes and other conditions. Then we have is post get. Post get provides the possibility to control the state of an output via HTTP post get requests. And the scheduler can be used to configure a timetable of when an output should be turned on or off based on days of the week or month and hours of the day. One another feature is GPS. GPS is a space-based radio navigation system, and it is used to enable the GPS service, and it supports the different types of satellites. We have map displays, we have NMEA page, we have uh, this is how the map displays look like. It will show you the different coordinates. Once all you need to do is just to add in the GPS antenna. Then we have NMEA page to configure settings to collect and forward NMEA sentence. We have HTTPS to configure data sending. We have AVL and GPS geofencing. One another useful feature is events reporting. Events reporting feature provides the possibility to configure rules that inform via SMS or email when certain trigger events occur. And lastly, we have package manager. So this is like your device's app store. Here you can browse available software packets or you can upload your own application. This package is a service used to install additional software. So to install a new service, locate the necessary package in the list and click the plus button that you can see here on the right, and you will be able to install the device with an available version. Some of them examples like are speed testing, Azure IoT Hub, BGP, DDNS, DNP3, then some language supporters, NQTT, SNMP, etc. Lastly, we have the system. This is like basically an administration system where you can you can manage your remote and local access to the device. You can download the troubleshoot files, generate certificates. You can download and upload the firmwares. You can export and upload backups, set up visiting, and reboot the device itself. So this is how all the four of them segmentations are done in the web UI, and it's very easy to use and quite friendly. That's all for today. Thank you.
Awesome. Thank you very much for that. I think we have a few questions that have come through. So just to quickly introduce myself, my name is Alex. I am the Leader National Trainer. If you guys have any questions to pose, please put them through now. We're happy to answer them. Some of the questions that came through that I just want to quickly pose to you is one question here that asks, can the Teltonika devices automatically fail over between different SIM cards if one SIM card is down or runs out of data?
Yes, absolutely, it can. So the thing is that we have few of the devices which has two SIM cards. So you can change it to a different, but not all the devices have dual band. So one of the device, supposedly if we have a Route 955 with us, you can set it up with your mobile SIM wired and wireless. But if you have a Route X12, you can add in your mobile SIM 1 and SIM 2 because both of the SIMs work together. But in root 955 devices, we don't have both the SIMs working all together. So for that, failover is a little difficult.
Okay, perfect. Thank you.
Yeah.
Quick question here as well. It asks, can Teltonika devices do site-to-site VPNs?
Site-to-site VPNs, yeah. So we have OpenVPN. So for that you can use, for site-to-site you can use OpenVPN.
Perfect. Another question here that asks, is it necessary to schedule the rebooting, or is
Yeah.
that just a best practice?
It's not necessary that you need to do reboot scheduling, but it's good. Sometimes what happens is, under no matter how the circumstances are, if you keep it like that, the device will just reboot by itself. So it's just like, probably we could say that if some issues come up and if something goes wrong, once the device reboots itself, it will refresh it, and probably that issue can be resolved without you even getting to know what the issue was. So
Correct.
it could be a good practice, but it depends on what your configurations are. If it is not necessary, then it's all right.
Perfect. Question here from Matthew as well. How do you set up the RUT240 to be a failover for the second WAN port on a UDM? Oh, sorry, on a modem.
What it was? Sorry, failover for?
So how do you set up the RUT240 to be a failover for a second WAN port on a modem?
So if you have both of them up, all you need to do is just to get into it, set up a priority, and that's all.
Okay,
Because
perfect.
it
Matthew,
just has one SIM, right? So it has, you can set up your wired WAN, your mobile SIM, and your wireless, and you can just set up, just put in a priority that I want this to be my first priority device. Supposedly it's wired WAN, then connect that, then next will be my mobile SIM, and whenever you lose the connectivity, it will just switch over to the next WAN.
perfect. Matthew, if that answers your questions, please do let us know. If not, we're happy to expand on that.
Yeah.
There's another question here that asks, do the serial interfaces only work with certain brands of devices, or is it universal?
The serial interfaces, it's only with not all the devices, but those devices that has the RS-232 and RS-485 ports. So not all of the devices have that, but whichever provides that, you can do the serial communication with Modbus and MQTT. Yeah.
One of the last questions here, can the GPS be used for vehicle tracking as well?
Absolutely, you can use that for vehicle tracking, and we do have an additional remote monitoring system, that is RMS, through which you can actually track all your devices, like multiple devices at once in your map location itself. You can use your WebGUI itself as well, and you can get the coordinates after every time. Yeah, it depends on how much time you are setting it up, and you'll be able to get the live location, like the tracking of it, information about it.
Right.
But it's just the coordinates, the longitude and latitude of it, yeah, from the web.
Perfect. Last question that I've seen here is, does Teltonika recommend any specific package repositories for downloading packages?
Well, it mostly depends on what your configurations are. But yeah, supposedly if you have, like an example, if you have something like uploading or downloading speed, if you want to check it, you just go into the package manager and download the speed test, and you can do some speed testing. So then we have Azure IoT. If you want to send the data to a cloud, you can use the Azure IoT Hub. So these are some of the features. It depends on what actually you're planning to do. But yeah, if it supports the open up WRT package, yeah, you can definitely use them.
Perfect. I don't think there's any other questions. If anyone has any additional questions, you're more than welcome to pass them through. Obviously, from Leader's side, you're welcome to send it through to webinars@leadersystems.com.au, and we'll obviously put you in contact with the team at Teltonika should it be required. That's it from my side. I see there's a raised hand there, so let me just see if there's anything that needs to be addressed. If you guys have additional questions, you're still welcome to post them through now should you wish. Not seeing anything else come through. Okay, with that, I think we can call it a day. If you guys have any additional questions, please do feel free to send it through to us. We will reach out to you afterwards as well. That's it from my side.
That's great.
Awesome. Thank you guys so much. Look forward to seeing you all in the next one.